Hey guys, welcome to the channel. In today's video, we are going to learn how to solve integration by parts easily by using Hindu, or better known as tabular method. Before we begin, I want you guys to please subscribe our channel so that you get updated with all the new tricks and tutorials as soon as we upload our new video. In order to understand this trick, I have divided this tutorial into 3 segments as per the different question which comes in integration by parts. So make sure that you watch this video to the end, as in each segment we will be solving a particular kind of question that is a part of integration by parts. So guys, we start with the type 1 where repeated differentiation of u gets equal to 0. Now you must be wondering, what is u? Most of us use u and v in order to represent the by-part integration. So in this example, where integration of x square cos 3x dx is given, we consider x square as u and cos 3x as v. Now, the idea behind choosing this as u is that we must choose u which is easily differentiable. Okay, and the v must be easily integrable or can be easily integrated. So I feel like x squared can be easily differentiated and cos 3x can be easily integrated. So that's why it becomes u and it becomes v. Now here we get the first type where it says the repeated differentiation of u gets equal to 0. As we know that x squared when differentiated several times will lead to 0, that's why we consider it as type 1 kind of equation. So let's start. We create a table of d and I. Now in D, we are going to simply write what is given in U. So we write here x square and over here we write cos 3x. Now one by one we will differentiate this column and one by one we will integrate this column. So differentiation of x square gives us 2x. Integration of cos 3x gives us 1 by 3 sine 3x. Okay, let's move further. 2x differentiation gives us 2. 1 by 3 sine 3x gives us 1 minus of 1 by 9 cos 3x. We move it further and differentiation of 2 is 0 and the integration of the above is 1 by 20 minus of 1 by 27 sine 3x. Now after we are done with this, we put some symbols over here. This goes positive, then negative, then positive, then negative. This is alternate. Okay guys, so now the next thing is to multiply crossly. That means the first element is multiplied with the second element, the second with the third, and then third with the fourth. We don't need to consider this one, only these three are required. So what we are getting as we move further, we are getting x. This plus will be ignored as it is not necessary to put by 3 as we have multiplied this. Then minus into minus, it turns out to be positive. Then 2x by 9, 2x cos 3x upon 9. Now this positive, negative, negative. 2 sine 3x by 27. Now this is what our question was: x square cos 3x dx, which is equal to this plus c. So guys, you can see this is how easy and simple this technique is. Let's move to the type number 2. So guys, let's start with the type 2. Type 2 states when the table gets the same elements as present in the question. That means when we construct the table of D and I, we are going to get the same elements as in the questions. Let's do it with an example. So I'm going to consider this as U and this as V. So we shall now construct the table D and I. Integration, we first write it as the original one. Now let's start. Differentiating e raised to the power 2x is going to give us 2 e to the power 2x. Cos x will be integrated to sin x. We move further, it gets to be 4e to the power 2x, and now it will be minus cos x. So we can see we are again back to the original question as e to the power 2x and cos x, the same as before. Let me show you this and this. So there is no meaning of doing it further because we are going to end up with the same routine. So we stop there and now we move to the next step, which is to provide plus, minus, plus, multiply this, and now here's the twist in our trick. We are going to multiply this with this in integration. Got a little confused? Don't worry, let's do it so that you understand it. So we are having the question e to the power of 2x cos x dx, which is equal to e to the power 2x sin x, e to the power 2x sin x minus 2e to the power minus cos x, that comes out to be plus 2 e to the power 2x cos x, then minus cos x is multiplied with 4e to the power x in integration. So plus minus is going to be minus integration 4e to the power 2x cos x dx. So you understand, guys, what does that mean? The third step would be multiplying the last two elements in an integration. Now if you guys look closely, this term and this term could be equated. So if I take this one to this side, to the LHS, we can get an addition of these two elements, which will give 4 plus 1 5 integration of e to the 2x cos x dx, e to the power 2x sin x plus 2 e to the power 2x cos x. Now we shall divide the entire equation with 5, so we are getting e to the power x cos x dx, which is our question, and our answer is e to the power 2x sin x plus 2e to the power 2x cos x by 5 plus c. That's how it's simple it is. Let's move to the type number 3. So guys, let's start with the type number 3, where x is in the denominator. That means we will stop constructing our DI table as soon as we get an x in the denominator. Let's carry it with an example. So we are having x cubed natural log of x dx as our question. So in this time, I'll consider natural log of x as u and x cubed as v, because it's easy to differentiate natural log than to differentiate x cubed. Also, this follows the rule of Eilhart, where logarithm comes before algebra. So let's begin. D I. I'm going to write natural log of x in D and x cubed in I. So the differentiation of natural log x is 1 by x, and integration of x cubed is 1 by 4 x raised to 4. Now, as soon as we see x in denominator, we stop and we continue our next step, which is multiplying this. My mistake. We should first give it symbols of plus minus. Then we multiply this with this, and we multiply this with this, and put an integration. That means, just like in previous step we did, we'll do in this one, log of x dx. As we know, guys, this is our question. So let's move further. We get x raised to 4 natural log of x by 4. Now this is going to be in subtraction, integration of x raised to 4 by 4 into 1 by x dx. This is what we are getting. We can easily calculate this one, which is, and now 1 by 4 could be ignored as constant, and we are left with x cubed dx, which can be simply integrated as 1 by 4 into x raised to 4 plus c. That means x raised to 4 log of x upon 4 minus x raised to 4 by 16 plus c is our answer. That's it, guys. This was our type 3. So we have pretty much covered all the kinds of techniques in these 3 types. Hope you like this video. Don't forget to subscribe my channel for more amazing videos of these tricks and tutorials.